Anthropogenic global warming presents a convergence of three distinct histories, each operating at different scales and speeds. They are the Earth system's history, the history of life including human evolution, and the history of industrial civilization. This collision challenges our conventional understanding of time as humans find themselves straddling processes that span millions of years alongside those that unfold over mere decades. Language itself reflects this temporal dilemma. Consider our distinction between renewable and non renewable energy sources. While we deem fossil fuels non renewable within human timescales, geologist Brian Lovell suggests they are technically renewable on a geological scale as new oil reserves for millions of years. Paleoclimatologists provide critical evidence for anthropogenic global warming, drawing from ancient ice core samples dating back over 800,000 years and records found in fossils and geological materials. Geologists within the oil industry have highlighted deep climate histories such as the late Paleocene Eocene thermal maximum, which occurred 55 million years ago and disrupted Earth's climate for over 100,000 years, long before humans existed. The implications of anthropogenic climate change extend far into the future, as emphasized by titles like David Archer's The Long Thaw: How Humans Are Changing the Next 100,000 Years of Earth's Climate. Fossil fuel emissions, with their long atmospheric lifetimes, could impact the climate of hundreds of millennia after the fuels themselves have depleted. This presents a challenge for policymakers and politicians who typically operate within much shorter timeframes. While policy specialists think in terms of years or decades, politicians often focus on electoral cycles. Bridging these disparate scales of time is crucial for developing effective climate policies. Understanding anthropogenic climate change requires grappling with timescales that transcend human measures. Despite the apparent irrelevance of million timescales to political decision making, the lasting impact of climate change underscores the importance of considering these slow geological processes in our response to the crisis. Anthropogenic climate change reveals significant gaps in our understanding, manifesting as rifts between cognition and action, and between human scale thinking and the vastness of planetary processes involved. These rifts challenge us to simultaneously navigate different scales of time and thought, injecting contradiction into our approach to the climate crisis. One such risk is in the transition from familiar probabilistic thinking, dominant in modern economies, to grappling with the radical uncertainty inherent in climate change. While economics typically distinguishes between known risks and unknown certainties, the physics of global warming often appears as a set of predictable, static relationships of probability. However, this perspective overlooks the nonlinear nature of climate systems and the potential for tipping points, as emphasized by paleoclimatologists. Policy discussions often treat climate change as a known variable to be managed through human ingenuity and political action. However, this approach may underestimate the unpredictable nature of climate systems and the potential for them to act as wildcards in human calculations. Conversely, climate scientists often employ a more vitalist rhetoric, likening climate system to a living organism. This perspective highlights the interconnectedness and dynamism of Earth's systems, emphasizing the need for caution and respect in our interactions with the planet. This tension between probabilistic thinking and the dynamic, complex nature of climate systems underscores the need for a more nuanced understanding of the climate crisis. Moving forward, it is essential to bridge these rifts and develop perspectives that account for both the global and planetary dimensions of anthropogenic climate change. Hansen's use of the term lethargic to describe climate change highlights a vital aspect often overlooked in economic and political discourse. While the timescales of glacial interglacial changes may span thousands of years, climate induced climate forcing operates on much shorter timescales, causing significant changes within decades. This sense of urgency and dynamism in the climate system is captured by Hansen's choice of words and reflects the uncertainties inherent in predicting climate tipping points. Unlike the deterministic view often favored in economic and policy discussions, climate scientists acknowledge the inherent unpredictability of Earth's climate. Climate models struggle to simulate past abrupt changes, indicating a complexity that defies simple probabilistic calculation. The climate is likened to a beast exhibiting behaviors that are not fully understood or unpredictable. This vitalist perspective underscores the need for humility in our attempts to manage the climate. While economists seek detailed probabilities to inform decision making, climate scientists recognize the limitations of such approaches. Climate uncertainties, including the potential for catastrophic tipping points, challenge traditional risk management strategies and call for a precautionary approach. The dilemma lies in balancing short term economic interests with the long term risks posed by climate change. While Hansen advocates for phasing out coal emissions as a decisive step, such measures may have profound economic implications, particularly for developing countries reliant on coal for energy. The uncertainty surrounding tipping points complicates decision making, leading to what Gardiner terms cost benefit paralysis. At its core, this rift exposes the mismatch between human centric timescales and the broader, more unpredictable dynamics of the planet. While paleoclimatologists view climate tippings, our risk management strategies are based on shorter term calculations. Bridging this gap requires a nuanced understanding of both human and planetary scales and a willingness to confront the uncertainties inherent in climate change. Human-induced climate change brings forth a plethora of justice-related issues spanning across generations, nations, and socio-economic divides. Peter Neville and Matthew Patterson shed light on the disparities inherent in the term human-induced climate change, emphasizing that while all of humanity faces the threat, certain individuals and countries disproportionately contribute to the problem while others bear the brunt of its consequences. This underscores the political and moral dimensions of climate change as articulated by Indian environmentalist Sunitha Narayan, who links climate change models of economic growth. John Bellamy Foster, Brett Clark, and Richard York further assert that at the heart of the climate crisis lies a social rift rooted in class-based domination, inequality, and ceaseless acquisition. This sentiment echoes a report by the United Nations which attributes the climate crisis to the uneven economic development patterns of the past centuries, primarily driven by the historically rich nations' disregard for environmental consequences. This perspective, championed by Indian environmental activists Anil Agarwal and Narayan, underscores the concept of common but differentiated responsibilities, highlighting the need for developed countries to take greater accountability for their past actions. However, it is crucial to recognize that the climate crisis is not solely a product of historical injustices or economic disparities. The root cause lies in the sheer volume of greenhouse gas emissions, primarily emitted by a handful of nations and a fraction of the global population. A hypothetical scenario of more equitable wealth distribution would not necessarily alleviate the climate crisis. In fact, it might exacerbate it due to increased consumption and carbon emissions. Thus, while historical inequalities undoubtedly play a role, reducing the climate crisis solely to a problem of capitalism overlooks the complex interplay of human history, earth systems dynamics, and population factors. Agarwal and Narain's advocacy for equitable distribution of natural carbon sinks highlights the thorny issue of population growth, often sidestepped in climate discussions. Population dynamics, while influenced by various factors including public health measures and economic development, cannot be solely attributed to capitalist exploitation. India's acknowledgement of its population challenges underscores the nuanced relationship between population growth, economic development, and environmental sustainability. Population remains a critical factor shaping the trajectory of the climate crisis. Governments in countries like China and India continue to prioritize coal fired power stations to uplift large populations out of poverty, citing coal's affordability as a key factor. Despite philosophical reflections on the balance between human need and greed, coal remains the favored energy source due to its economic feasibility. This demand for coal fuels a global market, with countries like Australia seeking to capitalize on export opportunities, further perpetuating coal's dominance in the energy sector. Moreover, population dynamics influence the climate crisis's impact on species expansion and consumption have long exerted pressure on biodiversity, evident in conflicts between humans and wildlife and the depletion of marine life. The exponential growth in human population, fueled in part by advancements in technology and agriculture, exacerbates these pressures. As global warming prompts species to migrate to more hospitable environments, they encounter barriers posed by human settlements, hindering their ability to adapt and survive. The irony deepens as human proliferation not only impedes the migration of threatened species but also complicates the plight of human climate refugees. The rapid pace of climate change leaves little time for mass human migration, contrasting sharply with historical periods where populations could adapt over millennia. This highlights the dual nature of human history. The short term impacts of industrialization and technological advancements intersect with the long term evolutionary history of our species. Both the rich and the poor are intertwined in this narrative, with modern energy and technology underpinning the sustenance of billions of lives on Earth. While per capita emissions serve as a crucial metric in climate discourse, they obscure the broader historical context wherein both affluent and impoverished populations participate. Population dynamics bridge these disparate histories, emphasizing the interconnectedness of human evolution, industrialization, and ecological impact. Understanding this complex interplay is vital for developing holistic solutions to address the climate crisis while acknowledging the shared responsibility borne by all segments of humanity. The climate crisis serves as a nexus or enjambment between the typically separate realms of recorded human history and the deep history of Earth's systems. This convergence highlights the intricate connections between the planet's carbon cycle and the evolution of life. However, this newfound awareness does not dampen humanity's relentless pursuit of its ambitions and conflicts. Stephen, Crutzen, and McNeil identify a period of the Great Acceleration from 1945 to 2015, characterized by exponential growth in various human activities such as population, GDP, urbanization, and resource consumption. This era coincides with widespread decolonization efforts and movements toward modernization and democratization worldwide. The surge in consumption during this period, including the adoption of consumer durables in Western households and the globalization of consumption patterns, symbolized a long awaited form of social justice, particularly in the realm of consumption. However, this pursuit of human progress has come at a cost: the near total appropriation of the biosphere by humanity. Human activity now accounts for a significant portion of terrestrial vertebrate biomass, primarily through livestock farming and agricultural practices. This unprecedented alteration of natural ecosystems has profound implications for global diversity and ecological balance. Moreover, the exponential growth in human population exacerbates these challenges, further straining Earth's resources and threatening the survival of numerous species. As humanity grapples with the consequences of its actions, questions of ethics and responsibility come to the fore. Broom acknowledges the ethical dilemma posed by climate change, particularly regarding the intrinsic value of nature. While he emphasizes the instrument value of nature for human well being, he stops short of delving into its inherent worth. Similarly, Archer underscores the humbling reality that humans are not biologically special and are merely a part of Earth's intricate web of life. The concept of human exceptionalism, rooted in religious beliefs and social constructs, has long shaped human perceptions of the natural world. However, indigenous cosmologies, such as those of Australian Aboriginals, offer alternative perspectives that regard humans as integral components of the natural world rather than separate entities. Durkheim's analysis of totemism further elucidates this notion, highlighting the dual nature of humanity as both human and animal. In confronting the climate crisis, humanity faces a profound reckoning with its place within natural order. This challenges entrenched belief of human superiority and calls for a re-evaluation of our relationship with the planet and its myriad life forms. Considering the insights from Fazlur Rahman, who explains the concept of qadar in Quran, which means both power and measuring out, and is closely associated with the word amr, meaning command, to describe the nature of God's relationship with humanity as mediated through nature. Rahman emphasizes that the all-powerful, purposeful, and merciful God measures out everything, endowing each element with its rightful range of potentialities, laws of behavior, and overall character. This measurement ensures the orderly functioning of nature, while also highlighting the profound difference between the nature of God and the nature of humanity. The Creator's act of measuring implies an infinite beyond which no measured creature can share. As Rahman explains, nature does not and cannot disobey God's commands and cannot violate natural laws. This perspective clearly indicates that humans must not usurp the role of God. However, it does not preclude humans from discovering and applying these laws for their benefit. God's kindness is evident in the provision of resources for humanity. Similarly, environmentalists often cite a verse from Genesis in which the Lord grants humans dominion over the earth and all its creatures, instructing them to be fruitful, multiply, fill the earth, and subdue it. The discourse on climate change rekindles an age-old debate on anthropocentrism versus non-anthropocentrism in environmental ethics. Anthropocentrism posits that the value of non-human entities derives solely from the utility to human beings, whereas non-anthropocentrism argues for valuing the non-human for its intrinsic worth. Feng Han suggests that human values inevitably stem from a human perspective, implying that non-anthropocentrism may be illusory. Ecologically minded philosophers have distinguished between weak and strong anthropocentrism, favoring the former, which involves rational reflection on the important human for human flourishing. James Lovelock's perspective on climate change diverges radically from this debate. He asserts in his book The Vanishing Phase of Gaia that considering the health of the earth without prioritizing human welfare is paramount. He emphasizes the Earth's health primary, as human survival is entirely dependent on the healthy planet. Lovelock even entertains the possibility of a drastic reduction in human population, suggesting that our current lifestyle may only be sustainable for a fraction of the current population without harming life. What does it mean for humans, inherently anthropocentric beings, to prioritize the Earth's well-being over human interests? How do we grapple with the notion that the earth was not created exclusively for us? Chakrabarty deals with these questions in the concluding section of this essay. In his critique of Chakrabarty's essay, The Climate of History, 4 Theses, Zizek raises important points regarding the relationship between anthropogenic climate change and the capitalist mode of production, which allows Chakrabarty to delve deeper into his final argument. Responding to his assertion that there are nature parameters to our existence as a species that are relatively independent of our economic systems, Zizek countered by suggesting that while the natural parameters of our environment are indeed independent of capitalism or socialism, the destabilization caused by global capitalism has profound implications. He argues that the fate of life on Earth is intertwined with the dynamics of the capitalist mode of production, signifying that the part, that is capitalism, now determines the fate of the whole, that is life on Earth. Zizek's viewpoint posits capitalism as the primary driver of the ecological crisis, whereas Chakrabarty's stance differs. Chakrabarty acknowledges that capitalism, reliant on cheap fossil fuel energy, is a significant contributor to the climate crisis. However, Chakrabarty contends that human history is entangled with broader processes of Earth systems and evolutionary history which transcend the scope of capitalism. These long processes, such as the Earth's million-year carbon cycle, operate on scales far beyond capitalism's temporal and spatial boundaries. Recognizing these deep-time Earth system processes as co-actors in the current crisis underscores the complexity of the climate issue. Unlike problems of wealth accumulation or income inequality, anthropogenic climate change could not have been predicted solely within the frameworks of political economy. Climate change is defined and constructed by climate scientists whose methodologies differ from those of political economists. The emergence of climate science has blurred the distinction between the global and the planetary. While globalization narratives typically center on human activities, climate science transcends human-centric perspectives. Scientists like James Hansen initially studied warming on Venus shifted their focus to Earth's climate due to rapid changes observed in the atmosphere. This shift reflects a broader trend in planetary science toward comparative planetary studies, exploring questions about the habitability of planets and the role of life in sustaining them. The climate crisis prompts us to confront their planet's alterity, its belonging to another system beyond human control. As Spivak notes, we inhabit this planet, yet it exists within a species of alterity. This perspective challenges us to recognize our role as temporary guests rather than possessive hosts of Earth. A comprehensive politics of climate change must acknowledge this perspective, grounding our quest for justice in the realization of our place within the broader context of planetary existence.